we've had some questions about how to complete some of the calculations on Unit 8 Worksheet 1. So I'm going to work through number 4, number 6, and number 9 to work through and talk about what you should be doing when you're solving these problems. So we're going to start with number 4. And I'm going to highlight the important things that I come to as I read through this problem. So an alcoholic iodine solution, which is a tincture of iodine, is prepared by dissolving 5.15 grams of iodine crystals in enough alcohol to make a volume of 225 milliliters. And here we're looking to calculate the molarity. So here's a couple things that I want to point out first. Okay, when we look at iodine, we have to remember, first of all, that iodine is a diatomic element, and so its formula is going to be I2. That's going to be important because we need to find the molar mass of iodine in order to convert grams into moles. So I'm going to start by doing that. Because it's I2, I'm going to look at the molar mass of iodine in the periodic table, which is 126.90 grams per mole. So to find my molar mass, I'm going to take 2 times 126.90 grams per mole, and that's going to give me 253.80 grams of I2 per 1 mole. Okay. I can use a proportion to solve for the number of moles that we have in 5.15 grams of I2. Okay. In order to do this, I'm going to cross multiply and solve for x. So here I'm going to get 5.15 equal to 253.80x. So I'm going to wind up with x equaling 0.020292 moles of I2. Now I took some extra significant figures here because this is not going to be the final answer. So in order to find the molarity, which is moles per liter, we're going to need to convert our milliliters into liters. You do not need to show work for that. Just divide by 1,000, we're going to get 0.225 liters. Okay, so if molarity equals x moles per 1 liter, here we can find this is going to be equal to 0.020292 moles for 0.225 liters. Divide by 0.225 liters, and we're going to get a final answer of 0.0902 molar. We want to round to 3 significant figures here because that's the number that we've been given in the problem for both the grams and the volume. Okay. Okay, so let's take a look at number 6. I'm just going to look at 6A, where we've got 0.25 molar aluminum chloride. We want to draw a particle diagram for this ionic substance and then find the molarity of each ion present. So if I'm looking at this, I want to start by figuring out the charges on my ions to properly draw my particle diagram. This is just like what we did in Unit 6. So looking at the periodic table, aluminum is going to have a charge of +3 as an ion. Each chloride is going to have a charge of -1. So to draw my particle diagram, I want a +3 ion and then 3 -1 ions. Okay. This also tells you the ratio of moles of each of those ions to the moles of 1 aluminum chloride formula unit. So we could say that if we've got 1 aluminum chloride, when it ionizes, we get 1 aluminum +3 ion and 3 chloride -1 ion. We can use those ratios to find the molarity of each of those ions compared to the molarity of the whole solution. So I'm going to use a solved proportion here. If I know that I have 0.25 moles of AlCl3 for every 1 liter of solution, and I also know that 1 mole of AlCl3 will give us 1 mole of aluminum ions, Then I can cancel the moles of aluminum chloride. I'm going to be left with the molarity of the aluminum ion only. And in this case, it's going to be 0.25 moles of aluminum plus 3 per 1 liter, which is 0.25 molar. Okay. Now, for the chloride, same process, but we have a different ratio. Okay, so 1 mole of aluminum chloride, Cl3 per 1 liter. This time we know that 1 mole of aluminum chloride is going to give us 3 moles of chloride ion. Again, we can cancel this out. We're going to multiply this by 3 to get 0.75 moles of chloride for every 1 liter, or a molarity of 0.75 molar. Now, if we take a look at number 9, this is going to be very similar to the problem we looked at on the previous page in number 4. Here we've got concentrated hydrochloric acid made by pumping hydrogen chloride gas into distilled water. If concentrated HCl contains 439 grams of HCl per liter, what is the molarity? Okay, so again, this is going to be another situation where we're going to need to use molar mass to convert from grams into moles. So this time I want to look up the molar mass of H and Cl from the periodic table. It's going to be 1.01 grams per mole for hydrogen plus 35.45 grams per mole for chlorine, and that's going to give us a total molar mass of 36.46 grams HCl per 1 mole. Okay, again, we can proportionally solve. If we have 439 grams of HCl, we want to find X moles. Okay. Cross multiply, find X. We're going to wind up taking 439 divided by 36.46, and our X is going to be, to some extra sig figs, 12.041 moles of HCl. And again, this one's going to be nice and easy because the volume's already given to us as 1 liter. So to find the molarity, you just want to divide by that 1 liter, round to sig figs, which for us is going to be 3, making this 12.0 molar HCl. Hope this helps clarify some things for you. If you have any questions, please make sure to send a message to your teacher.